Hi everybody, this is Mrs. Ellsworth. What we're going to be talking about in lesson 7-5 is factoring expressions. Do you remember what a factor is? Circle the factor or factors in this equation. Do you remember that you multiply two factors together and then you get a product? Okay, so factors are things that we're multiplying together to get one, right? To get the product. So, do you remember what a greatest common factor is? Like you guys can look at this and you can know that 2 goes into 4 and 2 goes into 12. But do you also recognize that the greatest common factor would be the largest one? So 4 would be it. We get a 4 and 4 goes into 12 also. You can also use a factor tree to figure out some of these, and I've got a neat way of showing you what to do with that. Okay, so when I look at this number here, I know that there's, or I should say term, I know that this is 4 times x. Okay, x, we can't do anything about that, it's just x, but 4 also breaks down into 2 times 2. So when you look at this, this is 2 times 2 times x. 2 times 2 times x. Okay, that looks great. Okay, on this one, we've got a 12 times x. Okay, so 12 is also 3 times 4 and 2 times 2. So this one's factors are 3 times 2 times 2 times x. For 12x, that's what our factors are. Kind of cool, huh? But that gets to take up a lot of space on your paper, and so I really want to see your work where it's supposed to be at, not on some other paper, because I can see people think like, oh my gosh, this is a mess, I'm not going to put it in the same square. So let's look at other ways to organize ourselves for the same exact terms. Okay, I can think of 4 as being 2 times 2 times x. Okay, that looks great. And then I can also think of 3 times 4, and then hopefully you can also say that 4 is not a prime number, so you need to go and change that into 2 times 2 times x. Okay, now let's find the greatest common factor of these two terms. Well, 3 is only in the bottom term, but 2, we've got 2 of those. Okay, here we go. We've got a 2 here and here. We've also got another 2 right here and here, and we've got an x. So, what is 2 times 2 times x? 4x. That is your greatest common factor. 4x, we knew it. 4 and 4, and then there's an x in both of them. 4x is our greatest common factor. So this is just kind of another way of looking at it. Why didn't we choose 3? Because it was not in both of them. If it's going to be a common factor, it's got to be common in both of them, and that one wasn't. Okay. So you've got some problems where they'll ask you what is the greatest common factor. Like look at this one. We've got 18a and 20ab. So 18a, I know one of the factors is a. Okay, I know that I can take a 2 into 18 and I will have 9 left, and I know 9 is 3 times 3. Okay, so let's think about this again. 3 times 3 is 9, times 2 more is 18, and then we get times a. Okay, now let's look at that with 20 AB. In fact, why don't we take a second here, have our substitute pause this, and why don't we process this just a little bit longer. Okay, so then now we've got 20AB. We've got A times B, and this time I decided actually to put the variables in front of the constants here, just so that you could just take a look at it and see that it doesn't matter what order that you go into. I do like picking a 2 or a 3 first, and I'm going to pick a 2. 3 doesn't go into 20, so I'm going to pick a 2, so it's 2 times 10. 10. 2 times 10. Well, I know that 10 breaks down into 2 and a 5. Those are both prime numbers, so 2 and 5. Okay, so what is my greatest common factor in these two? Let's look at it. We've got an A, and we've got a 2. That is it. So 2A is our answer to this for our greatest common factor. 2A is our answer. Okay, let's do it one more time. We've got 12C and 7G. Oops, I forgot C there. Okay, so let's go and look at this. 12 is, again, it's 2 times 6. Okay, and 6 is 2 and a 3. Okay, I got those down to all prime numbers. Okay, and then a C. 7 is just 1 times 7. There's nothing else. And then a G. There is no common factor here. So on some of these, your answers will be no common factor or none. Okay? Well, I want your teacher to pause this now, and let's take about 5 minutes or so and get some common factors here. So take a few minutes here and watch those pencils so that when they're starting to finish up, then you can restart the video. Okay. Okay, so now we've got 12. I'm going to push this up here. Now we've got 12 and 28C that we're looking at. Okay, we've got 12 down pretty good. We've talked about it several times. So 12 is 2 times 6, and 6 is 2 times 3. Okay, so 2 times 2 is 4, times 3 is 12. That looks great. Okay, now we can take a 2 out of here. So we got 2. Okay, 2 times 14 times 14. 2 times 14. So 14 equals 2 times 7. And then we got to remember that C. Now, sometimes you're going to have to get a little bit perplexed and be okay with that and use your calculator if you need to. I mean, you do have it for a tool, but try not to be dependent on it. Okay, so let's find our common factors. We've got a 2 and another 2. I don't see anything else that's in common here. So our greatest common factor, GCF, is going to be 4. 2 times 2 equals 4. That makes sense when you look at this. 4 times 7, 4 times 3, that sounds great. Okay, let's look at the next one here, 1B. 25x and 15xy. So some of you might be able to look at this and see what your greatest common factor is off the top of your head, but let's still use the same method. Okay, and we know that this is 5 times 5. There's no other type of factors. Okay, times x, and 15 is 3 times 5 times x times y. Okay, so we got that x in common and that 5 in common and nothing more. So our greatest common factor that goes into both these makes sense it'd be 5, and also it makes sense it'd be x. So 5x. 5 times x. Okay, so now we've got 42mn and 14mn. Okay. 42, I think of 42 and I think, oh, gee, that's 7 times 6. Okay, 7 times 6. So 7, and then 6 is 2 times 3. Then we got the M, and we got the N. Boy, that barely fits in there. Okay, and so then we got 14, which I think of 7 times 2, and then times the M and the N. How did I know what numbers? I just go down to prime numbers. That's the important thing. But I'm sure that you can see that I've got a couple things in common here. Quite a few. Okay, so the answer here is going to be 7 times 2 is 14. M times N. There we go. That's our common factor, greatest common factor. All these are factors of it. 7s and 2s are common factors, same with M's and the N's, but the greatest common factor is the largest one, so that's what we're looking for. Okay, so that's one type of problem that you have in tonight's assignment. Okay, the next thing. Let's factor these. Okay, so when you look at this, we've got a 3 that's in this, and we got a 3 that's in this one. Because you know that this one's 3 times 1 and this one's 3 times 3. You may still have to write out those factors, but I'm going to assume that we can do some of these in our head. The greatest common factor of these two is 3. So I'm going to take a 3. I'm going to write that a little bit lower. Okay, here we go. So now we've got a 3 out of there. when you go and divide this by 3, what do you have left? You've got an x left. And then here we've got, when you divide this one by 3, because again, we're factoring out of 3, so we're dividing it by 3. Okay, because this right here is a product, we're dividing by 3, and then what have we got left? So we've got a plus, and then another 3. Okay, something new. Okay, so what do you notice about the 3x plus 9 and the answers? Well, look at this. This is the distributive property. Do you remember? Let's go backwards on this. This is exciting. So we've got 3x, 3 times x is 3x, right, when we did the distributive property. And then we've got 3 times 3, so we get a plus 9. Hey, look at that. So we're doing the backwards thing with the distributive property here. Pretty cool, isn't it? Yeah. Anyway, so these two don't have any kind of common factors. 12 is going to be 2 times 2 times 3, and 7 is going to be 1 times 7. So you can't do any factoring here, so it's not possible. It's just not possible. You can't factor them. Okay? So you got to be aware of what's going on, and those ones are kind of nice because you don't have to do any of the math. I suppose you got a shortcut to the answer, right? Okay, so what I want you to do is I want you to practice this, and maybe you can notice 4 goes into both of these two. So that's pretty nice. You take a 4 and factor out a 4. 4 goes into 4x how many times? Just x times, right? Okay, and then plus, and then how many times does 4 go into 28? 7 times. But now you could go backwards, and you can check your work. 4 times x is 4x. 4 times 7 is 28. Cool. Try these two right here, and let's have the sub go and pause it, and then check it out when you guys are all ready. Okay, we've got 3 that goes into both of these. So we've got 3, and we're going to factor out a 3. So you can think of like, divide by 3, what do you get? A 1. Okay, divide this one by 3. What do you get? An 11x. Now, when students go and factor out a whole number and it's the same thing, sometimes they forget that 1. So that's why I wanted to show that. I didn't show that too well over here. So make sure you're thinking about that clearly. Okay, 4. 4 is 2 times 2. 35 is 5 times 7. Those are both prime numbers. There's nothing in common there, so this one's not possible. Pretty cool, huh? Going backwards from the distributive property. I didn't even check my work with this one. 3 times 1 is 3. 3 times 11x is 33x. There we go. Okay, moving on. Okay, so this one right here is pretty cool. I left all the notes on there for you, but I just wanted to look at our common factors. We've got 3 times 5 times x, and here we've got 3 goes into that times 6. 6 is 2 times 3. Okay, and nothing else. Whoopsie. So we've only got one thing in common here, and that would be the 3. So now what they're hoping that you can recognize is that you're adding these two things together on this. I'm kind of worried about running out of time. I hope I'm not going too fast. So here it is, and they want you to factor out a 3. So 3 goes into 15x 5x times, and 3 goes into 18 6 times. Okay, and so now you can just go ahead and distribute it and make this 3 times 5x plus 6. Okay, they showed it a little bit different way in the book, and so I decided to leave their notes up there so that if it struck a chord with your memory and doing them fine, that was great. I've only got 1 minute left, so I'm going to do a problem down here. Okay, let's look at this one. We've got 8 times 8r minus 14. Oh, I hope I can make it. So I only can see one greatest common factor in here, since this is 2 times 2 times 2, and this one's 2 times 7, and that is 2. Okay, so my answer is going to have 2 times the quantity of something. Divide this by 2, what have I got left? I've got 4r. Divide this one by 2. Oh, I better put my minus in there. Divide this one by 2, and you've got 7. Okay, so that's the answer to that one. So, well, this is due tomorrow at the beginning of class, so you guys have a good night, and I will see you later. Toodaloo!